Think about why do we need batteries? For electricity, right? Electricity is basically about electrons moving. The main idea is we need something to push electrons to make them move. That is where batteries come in. Regular batteries like lithium ones do this job, but you have to recharge them when they run out. But nuclear batteries are different. They are super reliable and last a really long time. They can work on their own for years, sometimes even decades without needing any fixing. So let's talk about how they do this. At the core of the nuclear battery is a small amount of radioactive material, usually isotopes like plutonium-238 or strontium-90. These batteries use the energy from radioactive decay to make electricity. These isotopes are picked because they give up different kinds of radiations, alpha, beta or gamma particles. This keeps making heat in the batteries for a long time. This is made by radioactive decay is put to good use in nuclear batteries. Inside the battery, there is something important called thermocouples. These are made up of two different metals joined at two ends. When the radioactive materials makes heat, one end of the thermocouples get hot while other stay cooler. So nuclear batteries use isotopes. Isotopes are radioactive materials that keep giving off energy. An example is radium. So how do they actually work? First, let's understand some basics about nuclear energy. Nuclear energy is released in different ways: fission, fusion, and radioactive decay. Fusion happens when two small atomic nuclei join to make a bigger one. It releases a huge amount of energy like what powers the sun. Making controlled fusion on Earth is hard because it needs really high temperatures and pressures. Scientists are trying to figure it out as a clean, long-term energy source. Then there is fusion, where a big nucleus split into smaller ones, making a lot of energy. Nuclear power plants like ones using uranium-235 use this energy by making fissions happens with neutrons making electricity. The third way is radioactive decay, which matters for nuclear batteries. It's when an unstable atomic nucleus changes into a small, stable one, letting out radiation like alpha or beta particles or gamma rays. For example, uranium-238 changing into a lead-206 over a time. This happens at a steady rate measured by the half-life. Half-life is how long it takes for half of the radioactive stuff to change. Radioactive decay is used in many things, like carbon dating to find out how old ancient stuff is. The use of nuclear batteries is a new thing. They were first used in the transistor for a satellite by the US in 1961. The satellite had a radioisotope thermoelectric generator (RTG) for power. These early nuclear batteries were made to give a defendable and long-lasting power supply for space missions. Later, Voyager 1 and Voyager 2 also used RTG technology to make electricity from the heat made by plutonium-238's radioactive decay. These spacecrafts are still working. Besides satellites, nuclear power is important in medical devices, especially pacemakers. These devices powered by nuclear batteries can last up to 8 years without needing new batteries. In pacemaker, a bit of radioactive material, often plutonium-238, gives off heat as it decays. This heat is turned into electricity using special materials, giving a steady and dependable power supply.